All right, so let's add to our understanding what decimals are. Previously, we've talked about terminating decimals. So let's kind of remind ourselves of what exactly a terminating decimal is and how that part worked, and then we'll transition over into repeated decimals. So let's take 7/8 for example. If you remember, we took the denominator, rewrote it into its exponent form, and we wanted factors of 10. We wanted to have 10 in the denominator, so in this case I would multiply by 5 cubed, both numerator and denominator, which gives me 7 times 5 cubed over 2 times 5 to the third power, which 7 times 5 cubed is 875 over 10 cubed. Okay, and then from here we would get that it would convert to the decimal of 0.875, so it terminates at that point. Okay. Similarly, we can use our division techniques to generate the same result. So I can say, well, 8 doesn't go into 7, but 70 goes into 8 times, gives us 64, with 6 left over. And I can drop another 0 down. Sorry, I put the decimal up there. And so 8 goes into 60 7 times, so that's 56. With a 4 remainder, and then we'll drop a 0 down, and 8 goes into 45 times. Right? So we get 0.875. But now that we have this division technique, let's take a look at something that we talked about was non-terminating and see if anything interesting happens. So let's look at 2 11ths underneath the same i's. Okay, so we'll take 11 into 2, and obviously it doesn't go in there, so we're going to take it out of 20. That goes in there once with 9 left over. And then we'll drop another 0 down. That's going to go in there 8 times, so 88 with 2. And then notice what's going to happen here. If I add another 0, right, we're going to get the same trick again, where it's just going to repeat over and over again. So 2 over 11 is equivalent to 0.181818, as much as I want to do with this, right? So let's talk vocab for a second. Anytime I see something like this happen, that's called a repeating decimal. Anytime I get a nice pattern where it goes over and over and over again, and the part that repeats, the repeated block of numbers, is called the repetend. And just to show you that math, we give names to everything. The number of units, the number of digits in the repetend. So how long is the repetend? So the length of the repetend is called the period. Okay, so the period of this repeating decimal happens to be 2. That's 0.18 as the component that repeats over and over and over again. Okay, and so notation-wise, whenever we see this, we're going to place a bar over the period length on the repetend. Now, I don't think you're going to be using that with your elementary school kids. You're not going to be pulling out the period repetend vocab. Not a bad idea. Wouldn't hurt to experience kids with upper level vocab words. So you would just say something like, put a line over the numbers that repeat, right? So let's take a look at a couple examples and just practice our different terminology here. Oops, let me get another space here. All right, let's convert 1/7 into a decimal. Hopefully we're convinced that it's not a terminating decimal because there's no way to get a factor of 10 to show up in the denominator. So we're going to go 7 into 1. Of course it doesn't go in there, so 7 into 10 goes in there one time with 3 left over. And then we'll drop that down and get a 0. That goes in there 4 times, so 28. Remainder of 2, drop another 0. It goes in there twice, so 14. The remainder of 6. Let's see, it goes in there 8 times. So that would be, sorry, I didn't drop the 0 down, so it'd be 56. So remainder of 4. Let's see, and so we drop that down, another 0. And that goes in there 5 times. I'm running out of space. Be careful on how much space I take on this. Alright, so 7 times 5 is 35. And drop that down and we get the 50. And that goes in there 7 times. So we get a 49. We get a 1. Alright, look where we're at. We are back out to the 1 again. So that means I'm going to get this repeating length of numbers of 0.142857 from here on out. Okay, so let me write this out. So 1/7 is equivalent to 0.142857. So that's our repetend with a period length of 6. So it's got 6 digits in the piece that repeats. Okay, let's look at one more example of this. Let's do 5/18. Okay, so 18 into 5 obviously doesn't go into that, so we're going to put a decimal digit there. And let's see, 18 goes into 50 twice, 36, and when I subtract that I get 14. We're going to drop the 0, and let's see, well, let's see, 10 would be 180, so it's not 9. I'm going to guess 7. Seems like a reasonable guess. So 7 times 8 is 56. And then, let's see, so 5 plus the 7, so 126. Okay, so that was a good guess. And then subtract that, and I get 14. Hey, what do you notice is going to happen here? I'm going to get this 140 over and over again, right? So, what's the piece that repeats? It's the 7, and it's got a period length of 1. So I've got 1 digit in the repetend. Okay, so let's start with, let's actually start with a terminating decimal, something that we've seen before, and just remind ourselves of how to convert that into a fraction form, and then we'll look at how a repeated decimal works. So let's say we got 0.55, which translates into 55 over 10 squared, which is 55 over 100, right? Well, what if, instead of that, what if it's just 0.5 with the 5 repeating? Okay. What I'm going to do is I'm going to set this equal to n, and I want to know what 10n is. Well, if I multiply that by 10, that's just going to move the decimal over one spot, and so I get 5.5 with the repeat, right? And then I'm going to do a little interesting algebra equation where I'm going to subtract 10n from n. And then notice what happens. On the left side, 10n minus n, I get 9n. On the right side, the repeating components all line up and they cancel each other out, and so I'm just left with 5. And so if I solve for n, I get 5 over 9. So 5/9 would be equivalent to this 0.5 repeating. Okay. Let's look at another example of this. of how we might go about doing this. A little bit larger pattern. So let's say we're going to look at 0.235 with the repetend being the 3 digits, all 3 of them. Okay. So what I want to do is I want to figure out a number, a power of 10 that I can multiply by that would give me a whole number but would leave the repetend, so I have that balance each other out idea. In other words, there's 3 digits in the repetend, so if I multiply by 1,000, then I would have 3 digits out over the decimal line, but then the other part would be just the repeating part. So it would look like 235.235 with the line on top. Okay, and then we're going to do that clever little trick with the subtraction. So 1,000n minus n. So 1,000 is 235 point with the 235 and the repeat, and n is the 0.235 with the repeat. And what do you notice when they're lined up? On the left side, I get 999n. On the right side, I just get 235. So if I divide by that 999, I get that the fraction is 235 over 999.